All right, domain and range. Let's get started. So domain and range is something that we talked about in Algebra 1, so it's something you've seen before. We're going to be revisiting it here, as well as going a little bit more in depth possibly with what you've seen before. So to get started, let's just start by defining domain and range. So domain we define as the set of all x values. Range we define as the set of all y values. So a set is just a collection of values, a collection of numbers. So all possible x values is the domain, all possible y is the range. So let's start determining domain and range visually from these graphs. So, and part of the way we can do that is by looking at lowest and highest values. So if we look at what is the lowest value x can be. So for this graph here, and it is a function because it would pass the vertical line test, our lowest possible x value. So I'm noticing the highest here is at 5. On the x-axis, we go all the way down to -1. So -1 will be our lowest x value. Our highest x value here would be at 5. What is the lowest value y can be? So our y values are y up and down axis. The lowest is 1. The highest is 7. And everywhere in between, so for x between -1 and 5 is good. Everywhere from 1 to 7. All these points exist. There aren't any like holes or anything. The graph doesn't stop at any point. So our domain and range would include everything in between. So the way that we represent that, the way we represent our domain, so it's our x value. So we write that from least to greatest. So it's going to go from -1 to 5. You'll notice I'm using these brackets. So we use brackets when it is including that value. So when we use a bracket, we're saying it is everything from -1, so including -1, up to 5 and including 5. If you did not want to include the value, like if you had a hole there or something, you would use a parenthesis, which we will get to. For our range, our lowest y value is 1, our highest is 7, so we go from 1 to 7. And again, brackets because we include those values. Okay. All right, let's try another one together. So again, what is the lowest value x can be? So as we look on the x-axis, it goes and it stops at -5. Our highest x value goes all the way to 4. Our lowest y value, so we've got this low point here, looks like it gets lower over here, so that looks to be -3. Our highest y value is up here at 3. So our domain, or all possible x values, it goes from -5 to 4, and it does include those points again. Our range goes from -3 to 3, and it does include those points. Okay. We'll do this one together, and then I'll let you try the fourth one on your own, because this one's a little different. So notice here, we have this one is not a function, because I can draw a vertical line, and it goes through more than one point. So it's not a function, but that doesn't mean it doesn't have domain and range. So as we're determining what's the lowest x value, so x is our left and right, I notice we have this arrow. So it's telling me it's going to go forever and ever up and to the left there. So our lowest x value is going to be -infinity because it's going to be going towards our -infinity on the left there. Our highest x value, so as we follow the graph, it goes around and stops there. So our highest x value is there at 3. Oops. 3. Our lowest y value, so the y value stops there at -2. Our highest y value, so as we follow the function, it's going up and to the left forever. So it's going to be going increasing, so up, positive, so we'd call that +infinity. Okay. So our domain, or all possible x values, will be from negative infinity to 3. And when you're writing negative infinity, because it's not an exact value, we actually use parentheses. And that's just always the rules with positive and negative infinity. You don't use brackets, you use parentheses with them. And it goes up to and including that 3, so we should have a bracket on that 3. So notice the parentheses and brackets on the left and right are determined by the leftmost and rightmost value. So you can have a bracket on the left and a parenthesis on the right, that's okay. Similarly, our y values go from -2 up to infinity. So we're starting and including -2, so always left to right, or least to greatest, and we go up to infinity. And infinity is not a number, so that's why we write it as a parenthesis. This is how the math conventions are. This is how you have to do it. You have to use parentheses with positive and negative infinity. That's just the way things are. Okay. All right. Why don't you try this next one on your own? As you're doing this, let's consider these having arrows. So going forever and ever. Pause the video, give it a try. Okay, we're back. So the lowest x value. So x, as we're moving to the left, I notice this is going down into the left forever. We don't sense an asymptote it's approaching or anything. So we can assume that's going towards negative infinity. It's going to go to the left forever. Our x value is going to go to the right forever. Similarly with our y's, it's going to go down forever and up forever. So there are a couple ways you can write this. So we can write negative infinity to positive infinity like so. Same with our range, so highest to lowest value. Or anything from negative to positive infinity, this is just saying any number. We call all real numbers. So we have a symbol to represent all real numbers. It's an R with like an extra line through it. This means all real numbers. So if your domain or range is going from negative to positive infinity, you can put that R in to represent all real numbers. Or you could write the words all real numbers if you prefer. All right, let's look at here, domain and range with ordered pairs. So remember, domain and range are sets of all possible inputs and outputs respectively. So if I want to identify domain and range for a set of points, so what this is saying is we just have 4 points. So if I were to graph this, I'd have a point 2, 7, 4, 11, 6, 15, and 8, 19. This is not saying those points connect through a line or anything. It's just saying we have 4 points. And it is a function. It passes the vertical line test. But our domain, or all possible x values, would only be those x values of those 4 points. So the way that we write that is we use curly brackets, and it would just include our set of all of our possible x values. Same with the range. It would just include a set of all of our possible y values. So we don't represent this as a range from like 7 to 19 because it's not connected. It's not saying we have a function between those 2 points. It's just saying all that exists are those points. Okay, and notice we write these from least to greatest. Always write from least to greatest. So here, with our second problem, as we are writing our domain here, it'd be x values from least to greatest. So -1 is our lowest, then we have 0, then we have 2, and we've got another 2, which is fine. You don't have to write it more than once. Our range, our lowest value is -5, then -3, then 0, then 3. Notice this problem, since we have 2 of the same inputs, 2 in this case, with different outputs, this would be a non-function. All right. Okay. All right, so I would be remiss to not tell you that there are different ways of writing domain and range. So we've been writing them with a list of ordered pairs, so using brackets and parentheses. There are other ways that you can write, and there will be ways that you see them because they're represented as possible x and y values. So as we consider this function here, this is a square root function, a radical function. It does have a starting point at 0, 0, and then it's going to go up and on forever. So as we consider writing this with its domain, so the domain is all possible x values. So it starts at 0, and then it's going to go towards infinity forever. So if I wanted to write this like we have been, our domain would be from 0, and it's including, does start there, and it goes towards infinity. Same with our range, actually. Our y value starts at 0, and it's going to go up forever. So y value is being range. If I want to write this, so this is how we write as ordered pairs, which is what we've been doing. We can also write it using inequalities. So domain is telling you all possible x values. So instead of saying from 0 to infinity using an ordered pair, you could just say all x values that are greater than or equal to 0. So this is saying from 0 to infinity. This is saying from 0 to infinity. It's just saying anything at 0, so close bracket, or equal to, and then larger. In the same way, we can write range that way, as y being greater than or equal to 0. So you can also use inequalities to represent your range using x and y, or I suppose you could use f of x here as well for the range. But that is an option as well, and it's something you will see, so that's why we mention it here. Okay. So let's look at a couple more problems and write our domain and range kind of in this special way. So for the next one here, we have this function. It's starting here at 0, 0, and it's going to 5, 0 there. Our peak here is at, let's see, 2.5 and 100. So our range, or sorry, our domain, remember, is x values. So our x values go from 0 up to 5. So if I want to write this in terms of an ordered pair, we start at and include 0, so it has to be a bracket, and we go up to and include 5, so it also has to be a bracket. The domain here, so again, it goes from 0 to 5, so we would have x values that are greater than or equal to 0, so starting at 0 and everything larger than it, as well as being less than or equal to 5. So it's another way of saying the same thing. We go from 0 up to 5. For the range, we go from 0 up to 100. So it would be from 0 to 100, or our y values have to be greater than or equal to 0 and less than 100. Okay. All right. Why don't you try this last one here on your own? So this is an open circle at -2, 2, and a closed circle at 6, 1, 2, 3, 4, -4. Give it a try on your own. Okay. Domain. So x values go from -2 to 6. In this case, we have to use a parenthesis because it's an open circle. It's not including -2, up to but not including, and goes to 6, which is including. So we use that bracket. So then when we're writing this as domain, it would be everything greater than but not equal to -2. So we just say x is greater than -2. And then up to and including, so or equal to 6. For the y values, we go from -4 up to 2. So it's including that -4, but not including that 2. So from -4 included, up to but not including 2. Alrighty. Okay, we're going to skip that next part. We'll get to that in our next domain and range lesson. So this is part 1 of domain and range. Remember domain, all sets of x values, range all sets of y's.